Today I'm going to be talking about Newton's laws of motion. But before I start, we must first understand what a force is. By definition, a force is a push or a pull of one object on another. Newton's first law, also known as the law of inertia, states that an object will maintain its constant velocity unless it is acted upon by external unbalanced force. Okay, today I'm going to be doing a demonstration showing how Newton's first law of motion works. What am I going to do is I'm going to add an external unbalanced force to the Age of Empires book, causing it to shoot out from under the bottle, and the bottle will fall into the cup. The reason the bottle will not shoot out is because I'm not applying any force to it, and therefore due to gravity it will just drop straight down into it. Alright, so now I'm going to do it, and I'm holding the cup because the cup is fairly light, therefore when I hit it, it'll shoot out too. So ready? There you go. Newton's second law states that an object's acceleration is proportional to the net unbalanced force acting on it and inversely proportional to the mass of the object, or in simpler words, acceleration equals the net force divided by mass, where force is measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second squared. Okay, as you can see, I'm no longer in my lab, so I don't need my lab coat. So basically what I'm doing here is I'm going to do a demonstration to show Newton's second law of motion. So what I'm going to do is I'm going to kick this board with a certain amount of force, and then kick the board again with the same amount of force, but with mass on top of it. So I'm going to kick it with this much force. So I'm going to do it again, just to show you my kicks are consistent. So I stopped at about the same place and accelerated at about the same speed. Now I'm going to do it with this tripod on top of it, and according to Newton, now this should accelerate less because I'm using the same amount of force, but there's more mass. So let's see what happens. As you can see, it accelerated quite significantly slower than the skateboard without the tripod, so this proves Newton's second law of motion. Newton's third law states that for every force, there is an equal but opposite reaction force. Okay, this demonstration today is going to show Newton's third law of motion. What I'm going to do is I'm going to apply a force on the hanger by pulling out, and that force will be hand on hanger, and we'll see if the force of the hanger on my hand is the same. So let's go. I'm going to apply a force of 2 newtons, and we're going to see if the force on the hanger is the same. And of course it is the same because Newton is right. So as we saw throughout the presentation, unless acted upon by an external unbalanced force, an object will remain traveling at a constant velocity. The acceleration of an object is dependent on the force applied on it and its mass, where the relationship is acceleration equals the net force divided by mass. Finally, the last thing we learned was that for every force, there is an equal but opposite reaction force.